Okay, dividing radicals. So very similar. Oh, just 1 second, sorry. There we go. So very similar to multiplying radicals. We can only divide when the indexes are the same, and coefficients with coefficients, radicals with radicals. So I'm going to go right into the lesson. So dividing radicals. To divide a radical, the indexes must be the same. That's those little numbers. So we divide numerical coefficients with numerical coefficients, radicands with radicands, and then we simplify. So root 70 divided by root 7. Well, 70 divided by 7 is 10, so root 10. When we have coefficients, we divide coefficients with coefficients and radicals with radicals. And so 15 divided by 5 is 3. 18 divided by 3 is 6. So 3 root 6. Going on, 20 divided by negative 4 is negative 5. 40 divided by 5 is 8. Now, simplify where possible. 8 we can simplify. If we look at the factors of 8, 1 times 8 and 2 times 4, 4 is a perfect square. And so we can break this into root 4 times root 2. We have negative 5 times 2 times root 2 because the square root of 4 is 2. And negative 5 times 2, we always multiply those two numbers. So that equals negative 10 root 2. Negative 10 root 2. Oh, undo. Negative 10 root 2. Okay, so again, dividing here, if I have x divided by x, it reduces itself out. So we're just left with root y. Next guy, 10 divided by 20. So when it's a larger number on the bottom, we're just reducing the fraction. So 10 divided by 20, and then you can go math, enter, enter, or just go straight to reducing it, is 1/2. 24 divided by 2 is root 12. Now 12, we can simplify, because if we look at the factors of 12, 1 times 12, 2 times 6, and 3 times 4, 4 is a perfect square. So we need to break down root 12. So we're going to write it as square root 4. Always put the perfect square first, times square root 3. And now we have 1/2 times square root of 4 is 2, times root 3. 2 times 1/2 is 1. So we just are left with root 3. So in some cases, it's easier to simplify first and then divide. So either would be fine. So what they're saying here is it says simplify the numerator and denominator, then divide. Okay, so 54, if I have a factor tree for 54, 1 times 54, 2 times 27, 3 goes into 54, 18 times 4, 54 divided by 4, nope, 54 divided by 6 is 9. And we know that 9, because remember, if our perfect square is on the right side of our factor tree, so we want the largest number, we know we're done. We don't have to keep going. But that's all the factors as well. So we want to break 54 into square root 9 times square root 6. 9 times 6 is 54. The factors of 8, 1 times 8 and 2 times 4, 4 is a perfect square. So we're going to rewrite this as 3 times square root 4 times root 2. We want to put the perfect square in front because that's what we're actually factoring out. If you wrote root 2 times root 4, it'd still be correct, but we want to break it down. So what is the square root of 9 on the numerator? It's 3, so we have 4 times 3 times root 6. On the bottom, square root of 4 is actually just 2. 3 times 2 times root 2. So that gives us 4 times 3 is 12 root 6. And 3 times 2 is 6 root 2. Now we divide. 12 divided by 6 is 2. 6 divided by 2 is 3. There's my simplified form. Remember, we only divide coefficients with coefficients and radicals with the same index by each other. Let's try another one. So I'm going to, we could also just start dividing by perfect squares, but the class seems to like the factor tree. So we're going to use the factor tree. So 1 times 26, 126 divided by 2, 2 times 63, I believe 3 does not go in. Let's try. Oh, 3 times 21. Let's try 4. 120. Oh, sorry, it's 126 divided by 3 is 42. There we go. Then by 4. No, 5 does not. It's not ending in 5. 6 and 21. So we haven't found our perfect square yet. Keep going. So 7 and 18. Keep going. Haven't found it yet. That's the only thing about using this method. It can take a little bit longer. So if we just start dividing by perfect squares, and 9 and 14 and 10, 11, 12 do not go into 126. So 9 is a perfect square. Took a little bit longer. So we have 8 square root 9 times square root 14 divided by, so now 112. So just move. Okay, sorry guys. I'm just going to move this guy over, all of this. So let's do a factor tree for the other guy. So making a factor tree for 112. 1 times 112, 2 times 63. So 112 divided by 2 is 56, sorry, way off. Divided by 3. Don't believe it goes in. Divided by 4, 28. 5, it will not. 6, no, 7, and 16. So there it is. There's a perfect square on the right side, so we're done. So we have root 16 times root 7. And so the square root of 9 is 3. I'm just going to write it above. So remember, we multiply those two numbers together. So 8 times 3 gives us 24 root 14. And the square root of 16 is 4. So 4 root 7. And now we divide. So 24 divided by 4 is 6. And 14 divided by 7 is 2. Now, if you were to type this into your calculator to check, you'd have to put in busy brackets. So to check my answer here, I'd have to type in bracket 8 square root 126, close the square root, close the numerator, divided by, open the denominator, square root 112, and there we go. So now type in my answer, 6 root 2, and it's the same thing. So just have to be careful when you type that all in. All right, so next page. Divide each term in the numerator by the denominator and simplify. So remember, even from polynomials, right, this root 5 is applied to everybody. And so when the whole thing is being divided by root 5, we're going to divide each one by root 5. So each one by root 5. Okay. I like to divide and then simplify, but both methods are fine. 20 divided by 5 is root 4. 20 over 5 is 4. 40 divided by 5, so you have a minus sign. Oh, sorry, this was a plus. There's a plus there, so plus. 40 divided by 5 is root 8. And square root of 90 divided by square root 5. So you can go 90 divided by 5. It gives you 18. So minus root 18. So now we want to simplify this guy. What is the square root of 4? It's just 2. Plus, we can simplify 8 because 8 can be broken down into root 4 times root 2. And 4 is a perfect square. And 18 can be broken into root 9 times root 2. So we have 2 plus square root of 4 is 2. So 2 root 2 minus square root of 9 is 3, so 3 root 2, and now we can collect like terms. So our final answer is 2 plus 2 minus 3 is just negative 1. So actually, minus 1 or minus root 2. Okay. If I were to check my answers with this one, I'd have to have invisi brackets around my numerator. Type in your answer and type in that. They should be the same. So going on, rationalizing the denominator. So in mathematics, we don't like to leave square roots on the bottom. And so we always try and get rid of a square root if it's on the bottom. And so that process of, I'm going to highlight this right here, the process of eliminating the radical from the denominator is called rationalizing. Basically, we're getting rid of the irrational number on the denominator. So if we have a rational in the denominator, we always try to get rid of it. This process involves multiplying the numerator and denominator. So how do we do that? We multiply the numerator and denominator by the radical denominator and then simplify. So the reason why it works is if I had root x times root x, remember that's just equal to the root x squared, or just x. It gets rid of the radical. If you multiply a radical by itself, it always gets rid of the radical. So root 3 times root 3 is root 9, or 3. And so if we multiply the top and bottom by that radical, we can rationalize it. So for example, it says rationalize the denominator. So we have 1 over root 10. So we're going to multiply top and bottom by the radical. So you just need the radical. So top and bottom by root 10. 1 times root 10 is root 10. Divided by root 10 times root 10 is root 100, or just 10. So here there's a root 6 on the bottom, and we want to rationalize the denominator. So we're going to multiply the top and bottom by root 6. 20 times 6 is square root of 120 divided by 2 times root 6 times root 6 is just 6. So we're left with root 120 divided by 12. 2 times 6 is 12. Now, if we can simplify any radicals, we must simplify them. So square root of 120, if we look at all the factors of 120, we better be sure that there's no perfect square factors. So, lucky us, let's look at the factors of 120. 1 times 120, 2 times 60, 3 times 40, 4, there's a perfect square, so we better keep going just in case there's more. 4 times 30, 5 goes into 120, 24 times, 6 will go into it 20 times, 7 will not, 8 will not, it's actually 8 will. 8 will go in 15 times, and I believe we're almost done now, because if 9 will not, 10 will, 10 and 12, and now we're done. And so the only perfect square here is 4. 4 and 30. 4 and 30. So we have to break that down. So we're just going to simplify this. So we have root 4 times root 30 all over 12. And 4 over 30, root 4 is 2. So 2 root 30 over 12. Oh, we're almost done. We're not done. Why? Because 2 over 12 we can actually reduce. What can we divide both of those by? 2. So it becomes 1 root 30 over 6. We reduce the fraction there. And there's our final answer. Let's move it right there. Okay? So sometimes there's a lot of simplifying that has to be done. Okay, so here we want to rationalize our denominator, so we multiply top and bottom by root 5. Now 18 times 5 is 90. So root 90 divided by root 5 times root 5 is 5. Now we can simplify 90. Now if we know our perfect squares, we can go straight into root 9 times root 10. I know 9 is a perfect square, and so we can square root 9, and it equals 3. So 3 root 10 over 5, and we can't simplify 3 over 5, so we are done. And that's rationalizing the denominator. It's getting the radical off the bottom. Okay, so express each numerator and denominator in simplest mixed radical form and then rationalize. So we're going to simplify first this time and then rationalize. So 500 we can break into root 100 times root 5 and 27. What two numbers multiply to 27 and one of them is perfect square? 9 times 3. So root 9 times root 3. So what is the square root of 100? It's 10. So 10 root 5 divided by 3 root 3. Okay, so we're done simplifying. It wants us to rationalize the denominator. So we don't want a square root on the bottom. So we have to multiply top and bottom by the square root of 3. Just by the radical. Just by the radical that's on the bottom. So we multiply top and bottom by the radical. I get 10. 5 times 3 gives us root 15. Remember, radicals with radicals we multiply. 3 times root 3 times root 3. What is root 3 times root 3? It's just root 9, or 3. So we have 10 root 15 over 9. And the 10 over 9, can we actually simplify that further? No. So that's our final answer. Try the next one. All right, 240. What can we break it out into? Now, 24 and 10 won't work. So look at our perfect square, our factors. 1 times 240, 2, 120, 3 and 80, 4 and 60. So there's 1. Maybe we can keep going. 5 will go into 240. How many times? So this is why dividing, when we have larger numbers, just dividing by the perfect squares can be a lot easier than writing out all the factors. Because then you're here, it could take a while. 6, yeah, 6 and 40. 7 does not. 7 does not. 8 does. 8 and 30. So far I only see 4, but there might be a larger one. Maybe 16 goes into 240. So keep going. 9 will not. 10 will. 10 and 24. 10 times 24. 11 will not. It does not go. 12 might. Guessing it does. 12 and 20. All right, so this is why, I'm going to show you the other way we could have solved this one. It would be a lot faster. 240 divided by 13 does not. Then we try 14. Then we try 15. Then we try 16. Oh, 15 times 16. Ah, finally. So all these factors it has. Wow. So see, you would have, if you stopped at 4, you wouldn't have been fully simplified. Okay, so how else could I simplify 240? Well, you just start dividing by perfect squares. So the first one we have on our list is 144. Then we have 11 squared is 121. Then 10 squared is 100. So we keep just dividing by the perfect square factors, then 81, until we get to 16. And that will be the only one that actually goes into it. So it could be a lot faster to divide by the perfect squares when we have larger numbers. Okay, so 240, we're going to break up into root 16 times root 15 divided by, now 108. Again, instead of actually writing out all the factors, let's divide by the perfect squares. So the first one smaller than 108 is 100. And then I'm going to try, next one on the list is 81. The next one on the list is 64. Then 49. Then there's 36. And there it is, 36 times 3. So root 36 times root 3. So I have, remember the square root of 16 is 4. So 3 times 4 gives us 12 root 15 over 6 root 3. So let's divide here. So can we divide 12 into 6? So simplify before we try and rationalize. 12 divided by 6 is 2. What's root 15 divided by root 3? It's 5. So we don't even have to rationalize this one. It simplifies nicely. try another one. So simplify the radical expression by rationalizing the denominator first. Alrighty. So there's two ways we can do this problem. We can either rationalize the denominator first, or we can simplify first. Now, I don't know if I would ever rationalize the denominator first, but you can. It doesn't matter the order. So we multiply the top and bottom by the square root of 2. I'm going to put it in front here because we have to use distributive law. So I'm multiplying top and bottom by the root 2. So root 2 times 2 root 50. So remember, coefficients with coefficients, radicals with radicals. So we're using distributive law here. So 1 times 2 is 2, and root 2 times root 50 is root 100, which is a perfect square. We'll get to that after. And then our coefficients, 1 times 1 is 1, and 2 times 14 is root 28, all divided by root 2 times root 2 is 2. So let's simplify our numerator. What is the square root of 10? 100. It's 10. So this just becomes 2 times 10, or 20. 20 minus 28, 4 will go into 8, and so is 16 actually. 16 times 2. So root 16 times root 2 all over 2. Okay, so this becomes 20 minus 4 root 2 over 2. And we're going to just bring that 2 to both of them. So 20 divided by 2 is 10, minus 4 root 2 divided by 2 is 2 root 2. Right, we divide the coefficients. So divided those coefficients and divide these coefficients. Coefficients with coefficients. And there's my final answer. Now, another way we can solve this problem is just divide each term by the root 2 first, and then rationalize it if we need to. We're going to distribute that root 2 to both. Okay, so remember radicals with radicals. So I have 2 root, what is 50 divided by 2? It's just 25, minus square root 14 minus divided by root 2 is root 7. Uh-oh. Well, let's get to that in a second. So 14 divided by 2 is root 7. Oh, 16 times 2 is not 28. I am sorry if you wrote this down. It's not. It's root 4 times root 7 is 28. There's my problem. So 2 root 7, we divide 2 divided by 2, which gives us the root 7. See, that's why knowing your times tables, making those little mistakes can really be bad. So 28, 16 did not go into 28, right? 4 does, 4 times 7. So that's where the mistake was. So here we go. That's why this method is so much easier. So what is the square root of 25? It's 5. So 2 times 5 is 10 minus root 7. And there's our final answer. So I find if you divide first, rationalize at the end if they ask you to. And that's it for this assignment. It's all done. So yeah, that's it for today.